Okay, we're trying to solve this trigonometric equation where this little 2 is a secant squared for x, all values of x between 0 and 2 pi, including 0. So the first thing I did here was move the negative 15 secant squared and the plus 17 to the right side of the equal sign, because I don't like to work with a leading coefficient that's negative. And then I realized I've got a tangent function here and a secant squared. If I could get all tangent, this might be easier to solve. So use the trigonometric Pythagorean identity that secant squared is tangent squared plus 1. Distribute the 15. Combine some similar terms. You get plus 15 minus 17 is negative 2. And now you've got a quadratic equation in terms of tangent. So you have to factor that. And I showed the steps to use split the middle, factoring by grouping. You could also use trial and error. But it does factor into 5 tangent x plus 2 times 3 tangent, the quantity 3 tangent x minus 1. Set each of these factors equal to 0. So the tangent of x equals negative 2/5, or the tangent of x equals 1/3. So to solve for x, we say x equals the inverse tangent of negative 2/5, of which there are infinitely many such angles. But we want the angles between 0 and 2 pi, or x equals the inverse tangent of 1/3, the angle that has a tangent of 1/3. To get those, I said x sub 1 is equal to the inverse tangent of 1/3, which that's radian measure right there. That's a first quadrant angle. So to get the other angle that has a tangent of 1/3, we want to move into the third quadrant, because tangent is positive in the third quadrant, by adding on the period of the tangent function, pi. So there's another angle that has a tangent of 1/3. Now when you use your calculator, you get the inverse tangent of negative 2/5. It gives you a fourth quadrant angle, but negative. And so we want to move into the first revolution in a positive direction around the unit circle. So we add pi units, and that takes us into quadrant 2. And tangent is negative in quadrant 2, so that makes sense. And if we add 2 pi to this, we'll go all the way around the unit circle to the same terminal side, but it will be between 0 and 2 pi. And here's a way to check your work. I rewrote the original equation as a function of x. And then where does that function or graph cross the x-axis? Well, you can see all these points match up with what we got over here. Okay, so there you go. I hope that helped. If you have any questions, post a comment.